When you watch an LLM generate a response, the text appears one token at a time. This streaming effect is not just for show, it reflects how the model actually works. But what is happening inside the GPU during that millisecond? How does the hardware decide which specific word comes next from a vocabulary of thousands of possibilities? The process is a sequence of transformations. Input IDs become embeddings, pass through multiple transformer blocks for attention, and feed forward processing, generate logits, and finally undergo sampling to produce a single token ID. It begins with tokenization. The model maps your prompt into a sequence of integer IDs using a tokenizer, which draws from a fixed vocabulary learned during training. These IDs are then converted into high dimensional vectors called embeddings. Because the attention mechanism is permutation invariant, the system adds positional encodings to these vectors so the model can distinguish between different word orders in a sentence. The data then enters the transformer blocks. It moves through dozens of layers where each token interacts with every other token in the context window. During this phase, the hidden state representation for each token evolves. Each layer refines the hidden state representation by considering surrounding tokens to build a more complex contextual representation. The feed forward networks then process these representations individually, applying patterns encoded in the model's weights while maintaining the relationships established by the attention mechanism. The core of this interaction is scale dot product attention. For every token, the model generates three vectors: query, key, and value. It calculates the dot product between the query of one token and the keys of all others to create raw attention scores. These scores are passed through a softmax function to turn them into a probability distribution, determining how much focus to place on each neighboring word. Finally, the model takes a weighted sum of the value vectors to produce the refined output for that specific layer. After the final transformer block, the hidden state passes through a linear layer. This produces a raw score or logit for every single token in the model's entire vocabulary. A softmax function converts these scores into probabilities. Finally, sampling techniques like temperature or top P select one specific token ID to be output. The model is not thinking ahead or planning its sentence. It is performing an autoregressive calculation, predicting a probability distribution over the next possible tokens based on everything that came before it, and then selecting one from that distribution. Your input text becomes vectors, travels through attention layers to build context, results in a probability map, and selects one token. That token is then fed back into the start to repeat the process.